Hello friends, in this video let us solve one problem of finding resultant of coplanar non-concurrent force system problem. This is coplanar non-concurrent force system problem given in sketch along with forces, because all the forces are passing through different points but are coplanar. Now let us find sigma fx first, that is summation of all horizontal forces. Here we have two forces acting in x direction, that is horizontal forces, and both are acting towards right. Therefore we have to take positive sign for both the forces, that is 2 plus 5 is equal to 7 kilonewton. Now let's find sigma fy, that is summation of all forces acting in y direction, that is vertical forces. Here we have two forces acting in y direction, these are vertical forces. Both are acting upwards, therefore we have to take positive sign for both the forces. 1 plus 4 is equal to 5 kilonewton. After this, let's find magnitude of resultant. R is equal to under root sigma fx square plus sigma fy square is equal to sigma fx value is 7 square plus sigma fy value is 5 square is equal to, let's find this value using calculator, root of 49 plus 25 is equal to square root of, answer is equal to, it is coming 8.60 kilonewton, 8.60 kilonewton. Then we have to find direction of resultant, that is angle. Direction means angle. It is given by this formula, theta is equal to tan inverse of sigma fy by sigma fx, tan inverse of sigma fy value is 5 and sigma fx value is 7, that is 5 by 7 is equal to 5 upon 7 is equal to inverse of tan. We are getting 35.53 degrees, 35.53 degrees. After getting magnitude and direction of resultant, we have to find location of resultant. For that we need to apply Varignon's theorem of moments. What is Varignon's theorem of moments? The algebraic sum of moments of all the forces about any point is equal to moment of their resultant, is equal to moment of their resultant. Out of these four fixed points, we have to select any one as a reference to locate resultant, in this problem I am taking or selecting A as a reference to locate or to give the location of resultant force. Now let's apply Varignon's theorem for all the forces. The algebraic sum of moments of all the forces starting from this force. Okay, as we have taken point A under consideration for taking moments of all the forces, see this 2 kilonewton force is passing through this point A. Therefore we will not get any moment for this force, because the perpendicular distance between line of action of force and the point is 0, as this force is passing through this point itself, A. Therefore skip this force for taking moment. Now we can take moment of this force. The line of action of this force is this, and the perpendicular distance between line of action of force and the point is this much. The side of square I have forgotten to write. Side of square given is side of square is equal to 2 meters. Now as side of square is 2 meters, see everywhere we get 2 meter distance. Therefore moment of this 4 kilonewton force is 4, magnitude of this force is 4 into this perpendicular distance is 2, 4 into 2. Now this will produce anti-clockwise movement, because when we fix this this point and apply upward force, it will try to rotate object in anti-clockwise direction, and we have to follow some sign convention for moments. Let us take anti-clockwise moment as negative moment and clockwise moment as positive moment. As this is anti-clockwise moment, let us take minus sign for this. Now this force, the line of action of this force is this, and perpendicular distance between point and the line of action of force is this. This distance is 2 again, therefore 5 into 2. Now if you fix this point, let me use some long object. Okay, if we fix this point A and if I apply force at other end in horizontal direction, then it will try to rotate this object in anti-clockwise direction. Therefore we have to take negative sign because we are getting anti-clockwise movement. Now this force, as this force is passing through this point about which we are taking moment, as line of action of force is passing through this point, we will not get any perpendicular distance between line of action of force and the point. Therefore moment of this force is also 0. It is to be equated with moment of resultant. Algebraic sum of moments of all the forces about any point is equal to moment of their resultant. Resultant value is R, and say this resultant is located at x distance with reference to A, at x distance with reference to A. Here we are getting the net moment value negative. What does it mean? The net moment is anti-clockwise moment. Therefore resultant should again produce same type of movement, that is anti-clockwise movement. For that we need to attach minus sign. Therefore the value of x is equal to minus 8 minus 10 upon minus r is equal to 18 upon r, and value of r is 8.60. 8.60 is equal to, let's find this value, 18 divided by 8.6 is equal to, we are getting 2.09 meters. 2.09 meters. Now let us look at resultant correctly in the sketch. If you see sigma fx and sigma values both are positive, what does it mean? The resultant should lie in first quadrant. Now the question is, see, we can place resultant here and here, out of which one is correct location. See, both are in first quadrant, but whether to put this resultant to the left of A or right of A, that is a question. See, resultant is producing negative moment, means anti-clockwise moment. If I place resultant here to the left of A, then what will happen? This is the distance, perpendicular distance between line of action of force, that is the resultant force, and the point. It will produce clockwise movement. Therefore this position is wrong. We are supposed to locate resultant to the right of A such that it will produce anti-clockwise moment. If you place it here, resultant, this is perpendicular distance x, that value is 2.09 mm. See, if you fix this point A and apply resultant force, it will try to rotate this object in anti-clockwise direction, which means this is correct. This is the correct position for resultant, and angle already we found it. It is 35.53 degrees. This is the location of resultant. That's it for this short video. Let's stop here. Thanks for watching. Goodbye.